My name is Komarek, and I will tell you some things I am working on at VIRTUALMASTER. So something about me, I am a Django developer, and I came to VIRTUALMASTER, which is Ruby only company, and I had to learn a lot of things just to work there and to be part of the team. So I came to VIRTUALMASTER at a time when they were planning big changes to their business and IT infrastructure because they were having some problems. And I am here to tell you what are the outcomes of this, and this is the story about the rocket. Okay, so the beginnings of VIRTUALMASTER date back to 2009, where two guys decided to create a startup to provide virtual servers for virtually everyone. So they soon got a lot of customers, and they had the product, the virtual servers, and everything went well up until they had to serve more than 2,000 nodes, and in this time some problems began to emerge which they didn't anticipate at the beginning. So they create the actual infrastructure is a monolithic application where you have all the services put together. You have the controller which handles the actual creation of virtual servers. Then you have the web front end to it, which does the graphical interface, so you can click your servers. Then you have some monitoring, billing, support services that come along all in one big Ruby application. So, and this is the root of the problems for it. So this is the picture of the, I hope you can see it. There are all the services that I was talking about connected with the SQL database, which serves like the heart of the whole solution. So this was the application we had to take care of, and it was increasingly difficult. So the first problem that we had to address were the scalability issues, because monoliths do not scale well as teams of 2 geeks. This doesn't scale well as well. So these were the first issues we had to address. Then we had some management issues. These were kind of related to the previous ones, but some core processes weren't defined well. There was no clear responsibility delegation for certain actions. The control was limited, and the lack of internal communication was very bad. So we had to say stop. This cannot go any further because it's hurting our business. So we had to invent something newly radical. So we decided to split the big problem into smaller pieces, and then we tried to put it back together using new technologies and new principles. Okay, so the rocket. The rocket, it's a symbol for us because it represents everything we want to have in our new solution. It has like control room, it has some pilot who is responsible for running it, it has some sensor array, it has even some kind of fuel. In our case, it's the money that the rocket generates. So if you don't generate enough money, you don't have enough fuel, and you just, fall. And we plan to launch the rocket at the end of the world this year, the 21st of December, for our customers. Okay, we hope it won't, be the end of the world. So this is what we think of the rocket. This is like a general overview of it. So now we'll talk a little bit in detail what happened when we broke up the monolith. So we split the original VirtualMaster application into core of virtualization providers. So in VirtualMaster, there were virtualization, billing, and the web front-end to it. Left just these three things to handle the virtualization part. And then we created the Robotice, and the Robotice is the name of our rocket. And to English, it could be translated like a she-robot, and we hope it will be a new word that comes to English dictionary from Czech, you know, after the robot, it's Czech word as well. So Robotice as a she-robot may well be there as well. So, and the Robotice took parts of the former VirtualMaster where it was handling configuration, monitoring, and gathering metrics. And in the future, we plan to split the billing system out of VirtualMaster as well and make it standalone solution so it can be used not just for VirtualMaster but for other applications as well. Okay, so Connect. These three protocols are like languages in which our new Robotice talks. We have a lot of REST APIs in HTTP. We have some message queue, and of course, some parts of our application still talk to the relational database, SQL, some. Okay, so when we were splitting the original VirtualMaster, we found a lot of undocumented processes, a lot of undocumented services, so we had to document all that, and document new processes and services we liked to have in our Robotica. So we had to describe everything, and then we could make some plans out of these documentations. And we tried to use service-oriented architecture to describe these services and processes. Okay, in this point, I would like to emphasize how open source and the community around it was in building this solution, because we have learned a lot from it and we adopted a lot of cool stuff. We use it, and now we are returning the favor and we are contributing to some projects we actively use. Okay, so now I will talk about the deployment part of the Robotice. So we use some config management systems like Foreman, Puppet, and Salt, which allows us to set up each servers and services it contains from the level of running it, monitoring it, and firewalling it. Security. So in monitoring, we switched from some Nagios solution into Sensu and Graphite, which is for us much more flexible, and we could even reuse our Nagios plugins, so the work wasn't that hard. We had some parts already done. We just had to set up the infrastructure for it and create some handlers. I will talk about this later. Okay, for management, we have used Redmine for a long time, so it was our #1 choice for management or work management software, and we use it. We had made some plugins into it as well, so we can communicate with our billing system, and it's connected with a monitoring system as well, where monitoring creates automatically tasks if something goes wrong. Okay, so we had all these different technologies, and we wanted wanted to put them together. So this was the, I think, most time-consuming part of the whole process. So in each technology, on each software, we had to figure out how to properly connect it. So first, we made some Kubernetes tests, some scenarios, how we wanted things look like. Then we had some apiary models. I think that was the last presentation here about apiary. So we designed our APIs and stuff, so others could work on it. Then we had to redesign some and create some Puppet modules, because there are tons of these and they often don't play well together. And we created some Sensu handler, which connects the most important parts of our system: the configuration, the management, and the monitoring system together. Then the Redmine plugins help us have control in workflow management, so we know what's going on and what's paid, what's not paid, and stuff like that. And the last part is the AngularJS dashboards. We use this very extensively because external dashboards, which just show the contents of the external application through some JSON API, is good that we could keep our brand. So we had one page, and we didn't care about the HTML of, let's say, Redmine or Sensu dashboard, which is different, each of these. So we had to normalize it and put together in some form of dashboards. So this is like brief description of our Sensu handler. Sensu handler kicks off when something goes wrong, when you have check and the check fails. So the Sensu handler looks at the foreman and it checks whether the failed service is of a customer that is listed for the monitoring. And if it finds the customer is listed for monitoring, that he is actually paying his bills, then this handler will create a ticket in Redmine for the operator or the pilot of the rocket to take care of it, to solve it. And this handler is on the GitHub, so you can look at it, and it's fully tested. Just if you want, grab it. Now I will talk in detail about the parts of the rocket. So we have some pilot with the crew. Then we have some sensor array and some controls that are used to fly the ship. Okay, the pilot, he is behind the steering wheel. He has the control and the responsibility at the time he is behind the steering wheel, and he has a supervisor at his disposal, so he can ask. He can ask for support if he is in trouble and he doesn't know how to run things or fix things. And the pilot is a key feature in our solution, because the rocket is always under some human control. So 24/7, there is always a guy who is watching the graphs, watching the outcome of the monitoring, and he watches clients' inquiries. So this is like our prototype pilot. This is actually senior pilot. He won't be sitting there for too long, and we plan to use some junior staff to handle late shifts on the watch, like as a pilot. And so this is how it looks like. So I will talk. I will talk now about the sensors. So the sensors are inputs for the rocket. The rocket doesn't get any inputs except of these. So on one part there are sensor or monitoring checks which come from Nagios plugins, or we have some graphite metrics that we have thresholds on, and if the value is higher than threshold, then it fires alert as well, and we check logs. Then we have some software tests. We have outcomes of tests as input for our Robotica as well, so we can react when some tests fail. And one of the most important things is the customer inquiries that is used for the customers to communicate with the solution and with us in some predictable manner. So we have some web form that users can use, or email, phone, Jabber. These are all channels that customers can use to get in touch with us. Then we have the controls. So as I said, the Angular JS widgets help us to control the whole thing, and it's pretty well branded. We have created many widgets that are flexible, and we don't have to use these tools directly, and we just use its power, its engines, not the web front-end. Okay, so what did this give us? So now we can support the multi-tenant architectures. That means that Robotice is designed not just to support the VIRTUALMASTer and its architecture, but it can support architectures of our clients as well, and we are using this feature already for some of our clients. So we watch us as well as them. Now with the creating of Robotice, we can now support better service level agreements that so we can provide higher quality services. We have now our infrastructure described as a code, so that means that we have full control over the infrastructure. We see what parts are there, what state they should be in, and especially the relationship between these parts and how they are connected. And if something goes wrong, we can see clearly what part is like damaged or which part is wrong. And by all these, we improved our quality management, that the solution we deliver to our clients are stable and pretty much predictable. Okay, so in the future, there are some technologies that we would like to expand to, or one of them is like Hubot. There are some plans to use this to automate some processes within the monitoring and configuration management. So, for example, when your web server crashes, that's the management, the monitoring solution will catch it, that something went wrong, that the server isn't responding correctly, and Hubot will check our model of the infrastructure and will find what can be done to fix this error, and if there are any dependencies to this error. Let's say if web application doesn't work, it may be the problem with the web server or the database, so it will find the root cause of the problem. So one thing for Hubot is to help the human operator to find out what's wrong faster by doing additional checks, and then it can actually do things like restart web server or restart the database, and if it doesn't fail, it will just pass the alert further. Then the OpenStack, VIRTUALMASTER in its core is a virtualization platform, and there are some new alternatives that can be used. So this is one of the ways we would like to follow. And the statsd for collecting the metrics on the application level and metrics for everything. Okay, and so this is and this is you can look at the presentation at the URL. And do you have any questions? Yes?
So you said you're going to be using OpenStack, right?
Yes.
What are you going to be deploying OpenStack on? Do you have any ideas?
Once more, where?
Yeah, what operating system are you going to be deploying?
I don't know. I think what's there? Some Debian or something for the open. You mean for the host nodes, where the? I think it will be Debian, but I'm not sure if that's what it's gonna be in the future. You know, actually now we were testing it on Debian, I think.